Okay, in this video, I will show you how to find the interval, but not to solve it until the end lah. It's just how to find the interval. So, in this picture, you can see that they have a paraboloid. Okay, this is from the question, exercise 2F, question 5 in book lah. Okay, this is the paraboloid with the equation y equal to x square plus z square. Okay, so this paraboloid in y-axis. Okay, so usually we found that the paraboloid is z equal to x square plus y square lah. But this one is in the y-axis of the paraboloid. And there are also plane which is the y equal to 3. Okay, the plane is in the red plane. You can see in the picture. Okay, so before this, we usually use in the cylindrical coordinate dz, r, dr, d theta. So for this objects, we can change to dy r dr d theta, because the paraboloid is in the y-axis, so we can change to dy. So to find theta is similar 0 until 2 pi. Okay, the theta is around the z-axis. So this is the theta. And for r, we can use the equation. So this equation is x square plus z square equal to 3. Because y equal to 3, then we get the circle is square root 3. So r is between 0 until square root 3. And lastly for y, so we can use the similar equation. Y is between x power of 2, sorry, it's not x power 3, x power of 2 plus z power of 2 until the y equal to 3. So now we have find the interval for all, then we can include in our integration lah. Okay, so now we have a dy r dr d theta. Okay, for next examples, these also examples from the exercise in books Q4A. You can refer in the books. Okay, the cylinder is x square plus y square equal to 9. Okay, then we know that the circle is a square root 9, which is 3. Then also plane, which is the equation is x plus z equal to 5. And they also have a purple plane, which is z equal to 1. So we want to find the volume between the planes. Okay, so the theta is 0 until 2 pi lah, because they have all cylinder 0 until 2 pi. And for to find r is 0 until 3. Okay, because the radius for cylinder is 3. And for to find for z, so that the below is the z equal to 1. Okay, before this, they have a mistake that's done by student. Student write the r is between -3 until 3. So that is wrong, because R will start at the middle, at the point 0, 0 lah, easily. And it's about until a circle. Okay, so R must be from 0 until 3 lah. But it's all depend on the question. R can be changed to other value also. Okay, and lastly lah for Z. Z interval is between 1 until. Okay, so now we have Z equal to 5 minus X. Okay, the next examples. Okay, this example in books Q4D. So the equation is for x square plus 4y square plus z equal to z square plus equal to 16. And if you draw this equation, you will get the ellipsoids. Ellipsoid, what is the ellipsoid? The picture is next to the ellipsoid lah. Okay, that is the ellipsoids. Okay, and they also plane z equal to 0, which is the above the z plane. Okay, so we want to find the volume above the ellipsoid. Okay, so the theta is 0 between 2 pi. Okay, to find for R, we use the equation when we set z equal to 0. So 4x square plus 4y square equal to 16. Then we can factorize. Then what we get is 16 divided by 4. So we get 4 lah. So square root 4, we get 2. So now we have R equal to 2. The radius for the ellipsoid is equal to 2 at Z is equal to 0 lah. Okay. Then lastly for Z. Okay. For here, R is different from phi for spherical coordinates. Ellipsoid is not suitable to use a spherical coordinate because the shape is not similar to spherical. Okay, for Z is from 0 until we use the equation again. Okay, so the equation is Z square equal to 16 minus 4x square minus 4y square. So Z is the square root. Okay, then we can include the interval for Z, which is 16 minus 4x square minus 4y square and square root. Okay, so you can see they have a x square plus y square. You can change to r square lah, but it will be a 16 plus 4r square lah. Okay. Okay, this is one example that sometimes students make mistakes. So you have a plane. So this plane could be like this. Okay, usually lah. From the equation we can find for the interval for x, it must be 6. Y 4 and Z is equal to 2. And when to write the interval, the student right interval for x is between 0 until 6, 1 for y, 0 until 4, and for z, 0 until 2. Then you write lah dz, dy, and dx. Okay. So this interval is wrong, because all is a number. When all interval is number, okay, when you get the interval all is number, basically this is a cube, So this is maybe the cube lah, for this equations. Okay. So the interval is wrong, and you need to calculate lah what you need to determine what is the right interval. So you basically use a vertical or horizontal strip technique lah in double integration. So you have a triangle, So this triangle, the line for that is we can use the equation, 2x plus 3y equal to 12. To get the 12 minus 2x divide by 3, that the equation for that line lah. Then we can write the intervals. So interval for x is between 0 until 6. Okay, interval for y between 0 until the equation which is 12 minus 2x divided by 3. And for z is between 0 until the equation is not 2. Sorry, it's not 2. So the equation for z is okay, 12. So the right equation for z is 6z minus 6z equal 12 minus 2x minus 3y. So we get z is okay, this equation lah. So that is the interval for z lah. 12 minus 2x minus 3y divided by 6. And lastly dz, dy, dx. Okay, that is the right interval for this plane. Okay, for the last examples. Okay, there is above y negative z. So the blue line is y negative z. Okay, I try to draw it because sometimes it's difficult because there is many plane here. So below xy plane, so they have a cylinder. So there is the below xy plane. And due to the plane y negative z, so there is a cylinder that cut by that plane. Okay, so you can see that. So I think better I use okay, this one, so I can rotate it. So what we want to find is the cut cylinder. Okay, so how to find the intervals? Okay, x square plus y square equal to 4. So the radius for the cylinder is square root 4, which is radius is 2. So the interval for r is between 0 until 2. Okay, there is the cylinder below the xy plane. So it's between negative 2 until 2. So for x is between negative 2 until 2. Okay. For this example, I use the Cartesian coordinate. Okay, to find the interval for y, so y is between, y is equal to square root 4 minus x square lah. So for y is between 0 until square root 4 minus x square. And due to the cylinder, the circle is below the xy plane, so we use a negative. Negative square root 4 minus x square. Okay. Similar lah if you use a vertical techniques. Okay, for z, the interval is between 0 until the plane which is y equal to negative z. I'm sorry, negative z. It cannot be the z equal to negative z, so we need to modify the equation. The y equal to negative z, then we get z is equal to negative y. So interval for y is between 0 until negative y. So that is the intervals for x, y, z. Okay. Then we write the integration. So x between negative 2 until 2, for y is between 0 until square roots. And for z between 0 until negative y. Okay, I'm sorry, it's supposedly because the circle is below. Supposedly the circle is negative 4 minus x square and until 0. Okay. Okay, that is the interval for z. Then dz, dy, dx. Okay, if dz, for the interval they have no z's for dz. Okay, so for example lah, if I change this interval to z minus y, so that is wrong because we cannot integrate. When we try to calculate, to integrate h, okay, we will get z, and z cannot be integrated until the end lah.